So in this section here we're going to be talking about continuity and one-sided limits. Now this may not be actually what you see when you push button 1 here. Of course I've got a bunch of different problems, but I just want to talk about continuity real quick here, and I don't know if we'll talk about one-sided limits in this video. Maybe I might mention something about it, but anyway, let's go over to the whiteboard here. Now what I'm going to attempt to do here is draw a graph, and so this is going to be kind of a crash course here on continuity. So I'm going to let f of x be our graph, and let's actually give it a color here. We'll give it green. How's that? And so let's say that our graph does something like this. Let's give it an asymptote in here. So there's an asymptote right here. Okay. And let's say that it comes up. And what else could we do here? Let's give it a hole, but then let's put a point right here where it is actually defined at a point, and then move the graph over. Okay. We're talking about continuity, and to check if a graph is continuous, if I can take my pencil and run it across and I have to lift my pencil up to get to the other side, well, we know this is not continuous. So the graph is not continuous, and we'll give this a number here. Let's say it's -3, and this looks like maybe 4, and we're just kind of guessing where some numbers are at here. And let's give this one 4, 8, 12. I don't know, this looks like maybe 12. Okay, so it's not continuous when x equals -3. It's not continuous at 4 because there's a missing point in the graph, it's undefined, and it's not continuous at 12. And you know what, we also need to define where this asymptote is. Remember, there is a vertical asymptote right here, and it's not continuous at 10. Now we give these continuities a name. This is a well, back when I was going to school we called that a jump discontinuity, but this is a non-removable discontinuity. They say this is non-removable, non-removable. This is removable actually right here. Now we actually have a definition of continuity. Okay, there's a definition of continuity. First thing, f of c must be defined. Okay, in other words, equal to a real number. And as you can see, when we plug 12 in, we actually, this is true. So far that follows the definition of continuity. The limit as x approaches c of f of x must exist, and in this particular case the limit does exist, okay, but that limit must be equal to f of c. So if this were L, and then this number here must equal this number, and as you can see it doesn't. This whole, the y value is different from this particular point right here. Alright, so that's basically continuity. I mean, that's the definition of continuity. This must exist, this limit must exist, and then they both must be equal to each other in order for, if we were looking at continuity at a point. Okay, and that's all. So as you can see right here, okay, the limit does not exist, so that fails and that fails also, right? This one right here, f of c, doesn't exist, okay, because we got a missing point. However, this does exist, but they're not equal, right? This must exist right here, right? And in this particular one right here, the limit does not exist, all right? So these are usually the three common ones, 1, 2, 3, or 4 common ones that you would see that would create that graph is not continuous. So that's all there is to continuity.